welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Chuck Sexton.
Hello, everyone, and thank you, William. Thank you, everyone, for tuning in to my case study Tech to Tech presentation today, the topic of which is new cleaning technology for remanufacturing of engine heads. So most of you probably know the remanufacturing industry worldwide has grown rapidly during the last 20 years. And if you go into a service center today for your car and you need a new engine, you probably don't get a new engine, you get a remanufactured engine. And they're so good today that generally they claim to be the manufacturers who do the remanufacturing, claim that they're as good as the original engine, and these engines come with warranties. So we see a lot of this activity for engine and for transmission remanufacturing. This particular case study I'm talking about today is the first significant customer that we won going back about 8 years ago. And they were kind enough to allow us access to a large production parts washer for about 2 years. And that's about as long as it took us to end up with a chemical product that was significantly better, and it lowered their cost and improved the overall performance of their cleaning operation. This since moved on to many other washers at this site, which happens to be in Mexico. And today we have a large number of customers that we have won. Cleaning's very difficult in this industry, and almost everyone we've approached has been eager to let us come in and try to improve their cleaning operation and lower their cost. The opportunity for both KaiZen and for the remanufacturing companies sort of centered on these three statements: remanufacturing of engine heads and other engine components involves aluminum and steel parts, and there's a very big trend toward aluminum replacing steel today in most automotive engines, which are heavily soiled with oil, grease, burned on carbon, and oxidation. Logistics issues, poor cleaning performance, and high process costs prompted this company, and many since then that we're working with today, to look for an alternative cleaning process. Burned on carbon after cleaning requires additional cleaning by way of media blasting, very expensive. You can see some of the carbon left on the part on the top right picture out of a conventional cleaning process. The gentleman with his arms through the extending into the media blast cabinet, and that's typical. We see that at many, if not most, plants we're in. I know of a couple of plants that have more than 40 of these, and they're very expensive to operate. And what that gentleman's doing is not the favorite job for most of the people working in these plants, and they actually rotate people in and out of that job. The challenge, again, is poor carbon removal, requiring extensive blasting after cleaning, higher costs for both labor and blasting media, high chemical cost and downtime due to short bath life and frequent bath change out. And this was, by the way, this was where we arrived. And this was the case when we arrived at this customer 8 years ago, and almost every customer that we have worked with since then. Complicated process control. In this particular case study, they were using a two-part chemical process, adding sort of part A and part B, just made everything complicated. What you see in these operations, in these plants, is sort of two phases of cleaning. So they bring in the engines, the first cleaning phase is in spray cabinets, cabinet spray washers, and conveyor washers to remove the sort of easy to remove oil and grease. And then you're left with carbon that you see on these parts on the right. Those parts have all gone through that first level of cleaning in the spray systems. And they do a good job with the oil and grease, but not with the carbon. And the carbon has to be removed. The best operation, which is what we see in most accounts that we're in, is vertical agitation with ultrasonics as sort of phase 2 of cleaning. And that's the process that really works best for removing the burned on carbon. I've shown the kind of vertical agitation with ultrasonics in this animation on the left. The two-part chemistry, this particular company was using one part at 7 and 9% and the other component at 2%. They were running at about 175 degrees Fahrenheit in 500-gallon washers, and they have quite a few of these. And we're in all of these now, by the way, and we've made significant improvements to this process. They were running a 7 to 10 day change out of the chemistry or 7 to 10 day bath life. Very expensive to change these machines out. Not only do you have to replace the chemistry, it's the time that it takes, but there's also a lot of wastewater that's produced when you do this. So the solution we ended up with, and again, this sort of 2-year R&D project, was to develop a chemistry we named Metal-Nox M6353. You can see some of the parts here on the right side of the screen cleaned by this process. 30-minute cycle time on average. Some parts are 20, some are 40, but on average about 30. Vertical agitation with ultrasonics again. And we were able to take the bath life or change out of the chemistry from what they were running 7 to 10 days to 20 days. And I will say that almost every company we've gotten into in this industry since that time, 8 years ago, is also running about a 7 to 10 day bath change out. And it saves a lot of money to move that to more than double the bath life. You can see the parts on the right, the level of cleanliness we're attaining. The solution, it's important to note that the concentration of 6353 is measured by either conductivity or titration. I'm going to put this up front here because this is always one of the first questions that our customers ask. I would say in 75% of the applications, we're doing titration and the rest are conductivity. This particular company in this case study are still doing, after 8 years, conductivity. The problem is if parts where there's a lot of oxide, aluminum oxide in particular, being removed, is it's metal salts and they dissolve in the cleaning bath, and that raises the conductivity to the point where measuring conductivity for purposes of determining the concentration of the cleaning chemistry is interfered with. So what we do when we start a new process up is we'll monitor it for about 2 months and determine which of the methods works the best, conductivity or titration. And we offer both. And it's a lot, I would say most of our customers are so used to using titration that is not a big deal. In fact, they're comfortable doing that. Conclusion, couple conclusion slides here. Metal-Nox 6353 replaced in this particular account and many since then the existing 2-part cleaning chemistry, resulting in twice the bath life and 80 to 90% better carbon removal and overall better cleaning cost. And I kind of split it up into 3 bullet points here. Lower cleaning cost are the product of less change out frequency, again 20 days versus 10 days by the old process, improved carbon removal. I show this manual blast cabinet again because it's really sort of, what's first and foremost on the minds of our customers when we talk about making an improvement is reducing the amount of time that people have to do this, reducing the amount of blasting media. We were able again to lower the average time spent per engine hit from 25 to 30 minutes to 2 to 5 minutes, and 80 to 85% less blasting media. And we ended up with a single part product and many of the chemistries. In fact, I think the best chemistry on the market 8 years ago required part A and part B. And once you mix the two, you can no longer measure the concentration of either one. Last slide, frequently asked questions on this topic. How important are filtration and oil skimming and removal for bath life? Short answer is they're both very important. In this case study, one of the first things we learned is that when the oil skimming stopped, for one reason or another, the bath life dropped off markedly. And these vertical agitation parts washers, normally the wash stage overflows into a weir, and that's where the oil skimming and removal is being done. If that's not working well, the bath life drops. And it's the same with filtration. You've got to maintain the fluid in these parts washer to really maximize bath life. What type of ultrasonics is best for carbon removal? We use and are using today both 23 kilohertz and 40 kilohertz. They both work very well. I think the common thinking in the industry is that for larger, heavier parts, the lower frequency might work better. I'm not sure we have data that proves that out, but I will say we're using both frequencies very successfully. Can we expect 100% carbon removal? And I like to point this out early on with our customers, because if their goal is 100%, we may not be able to get there in a cleaning process. But what we can do is significantly improve the carbon removal, the amount of media blast that's required at the end of the process. We're able to lower the cost, and we're talking about 80 to 90% improvements here. So just so everyone understands it, you might be able to find a speck of carbon somewhere, but our goal is to improve the process as much as can be done in a common standard cleaning operation. Thank you very much. That's all I've got for today, and I'll turn it back to William.
Thank you, Chuck. Thank you guys for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local KaiZen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description below. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.